Welcome, everybody. Good morning. Thank you very much for attending this talk, first talk of the day. My name is George. I'm here with Guillaume. We are committers to the Quarkus project, and here today we're excited to talk about all our great failures, right? And a few things that we did right over these past 6 years. So, Quarkus, right? We started work on it 2018, released first public version 2019, and we wanted to reinvent the way you build Java applications, right? We wanted to do something different, something that hadn't exactly, that didn't fit in with what the paradigm was back then of what the, let's say Spring Boot had like 90% of the market back then, right? So what was the big idea, right? The big idea that led the initial small group of people to start working on this and make a difference, right? That the first thing that came to mind back then. So the big idea was that you would, when you build the application, there would be a lot of code that would actually execute during build time. So when you do like an NVM package or a Gradle build, at that point, like with your normal Java stack, nothing really happens, right? A jar is created and a bunch of stuff gets added to the jar. But with Quarkus, the big idea was, and still is this day, right, that you would do a huge amount of work at build time, which would enable you to like do much less work when the application actually starts. So like very quickly, what we do is like we scan annotations, we scan configuration files. We build up a lot of metadata for the libraries like Hibernate or Hibernate Validator that we use. We generate a ton of bytecode, so we actually like write classes. If you look into the jar, there are a bunch of classes there. And we create our own special jar, which these days we call the fast jar, that takes into account how the JVM loads various classes in order to speed up everything, right? And then at runtime, the main class that is generated, which again you can see, but it's kind of well hidden. That main class has two big blocks: a block that runs in the static part of the class, and a part that runs like in the main, right? And the reason we did that is because when you use GraalVM to build a native image, everything in the static block is actually executed when you build the native image. And the advantage of that is that all the stuff that is done at this static init time is actually snapshotted, burned into the heap, and then when you run the native image, it's smaller, it runs faster, and you get much better footprint, right? Both in terms of RAM and in terms of size. So, okay, that was like the initial idea. That was the driver that said like this is what's gonna make Quarkus different. It's gonna make it better than what's already out there. But as things progressed, we figured out that, you know what, this is a very good building block to introduce things that make the developer experience so much better. So you have dev mode, which is our basic. When you develop the application, you don't run it like a regular jar. You don't run Java jar. You run like NVM Quarkus Dev or Quarkus CLI, where you enter the special mode that has a whole bunch of things like a dev UI and things like that. And like the most prominent feature that like most users of Quarkus see and are like extremely happy about is like live reload. So you edit your code. You don't have to restart the application. You just like continue, like refresh the browser and everything is just there, and it works without any configuration on your part. It works like 99.99% of the time. So it provides a wonderful experience. Then something that came like maybe a little later but builds on the same foundation is dev services. So dev services is the idea of like when you're using a database like Postgres or Kafka or something like that. If you have, and you're in the dev mode, if you have not configured a URL for like where Postgres is or where Kafka is, then Quarkus will start that service for you automatically, right? And then you can continue on working without having to deal with Kafka or Postgres. The same thing applies to tests, and the whole idea is that we want to make it extremely easy for you to get started, get working, work seamlessly along the way. And then the progression of that was the idea of continuous testing, right? So we had live reload where you reload the code, and then you change the code, you reload, everything just works. But then what we did is that, okay, there's this idea like, okay, what if I change the test or I change the code? Then the test can run automatically as well, right? So I get this continuous feedback of, I have a feedback loop that is very, very tight and gives me continuous feedback of how the application is doing in terms of testing. Well,
yeah, so it's been 6 years, a lot more gray hair, and we thought it was a nice time to reflect on what we did, try to take a step back, understand what we did right, what we did wrong, and well, that's nice. We did everything right.
We'll give you 45 minutes back, right?
Yeah.
So you can take no. We did a bunch of things that weren't so great, and we'll want to share that with you.
We have some more backup slides. So let's try to dive in a bit. The first thing is that we started a new framework from scratch 6 years ago, and it's a lot harder than when other people started frameworks 20 years ago. The Java ecosystem is a lot vaster than it used to be. You have so many libraries, some very obscure ones, but that are useful to people. A good example is we have a lot of people using very obscure test libraries, and they are important for them. And when you have an infrastructure that is so different than the other frameworks, sometimes you run into issues. So we have to take into account this vast ecosystem. And even with all the experience from GBoss EAP, Wildfly, the experiments we did with Swarm and Thorntail, it was still a lot to do. And even if we reused a lot of existing components, so we have reused so many components from the larger Java ecosystem, Jackson, and a lot of others. And yeah, still a lot of work. And it's also a lot of infrastructure to set up. 20 years ago, you could start your framework, have some basic doc, and people would be happy about it. Nowadays, you need to have amazing docs. You need to set up, obviously, CI, and it's quite a lot of initial work just to be able to say, okay, we have a new framework for you. Please have a look. So Quarkus really started as an experiment. We wanted to see if we would be able to reinvent a Java runtime for modern times. With Cloud Native, with this trend of microservices, would we be able to have a fast startup time, a low memory footprint? Would it be possible with Java? So this was really the idea of the experiment. And since then, there was a lot of organic growth. We built on the ideas we initially had. We put some new ideas in the mix. And sometimes it can be hard to just take a step back and reflect on these ideas and regroup and say, okay, maybe this wasn't that good. Maybe we should tweak that. We should probably redevelop this entirely because it's a bit messy. We already fixed some of these issues in the past few years, and we will address more in Quarkus 4 that we will probably release next year.
Okay, yeah, so let's start with some basics about what we did correctly, what we didn't. Okay, so if any of you have seen Quarkus on GitHub, right? It's a very large Maven project. So if you go and try and check it out and try and build it, the first time you build it, it will take forever because it's going to download like half the internet. So over 1,000 Maven modules in the core repository, right? Now that makes a few things easy. Like if you have it set up in your IDE, right? So people like us who work with it daily, when you have it set up in your IDE, it makes refactoring extremely easy, right? Because you have one repository, you don't have to change things in like 10 different places. You have one repository, like the IDE knows knows all the call sites of things. So that makes it extremely easy. Well, the other thing that makes X easier, let's say for Guillaume, because he does the releases, or most of them anyway, it makes it a lot easier for Guillaume to do a release. And that's been like, at least in the beginning, it was an enabler of how quickly you could do releases. Because in the beginning, like we didn't have all the automation we have today. And if you had to like release 10 different repositories, that would have been hard. So from the beginning, we tried to do like monthly releases. I'm almost certain that we've hit that target like almost always, right?
Yep.
With very few exceptions. But like if you have a project that is that big, like over 1,000 Maven modules, that causes problems in a few areas. First of all, like if you try to open it in, well, the latest versions of IntelliJ IDEA, that they work really well, the indexing, but like let's say a couple years ago, right? We had a ton of people saying, "Oh yeah, I opened Quarkus and IntelliJ just freezes, right? It doesn't work." And then so what they would have to do is like, okay, nah, you know what? I'm going to ignore like 100 different modules. I'm going to ignore Kotlin. I'm going to ignore like REST. I'm going to ignore everything. I'm just going to import my thing and work on that. But the good thing is that the fact that we created this structure and this massive monorepo, this pushed IntelliJ to make their indexing much better, because they even like had an open issue where they were using Quarkus as a benchmark for how fast they could index things. So I remember like a couple years ago, they went from like indexing it in like 1 minute to like 5 seconds or 10 seconds, right? So amazing. Then we also had same thing with Maven itself, right?
Yeah.
At some point.
Yeah, Central Portal has been problematic for us because we push a massive number of files, and yeah, we have been the benchmark when they started migrating things, and we arrived and they were like, "Oh, you pushed far too many files," and we're like, "Yeah, but I mean that's how it is, and that's how it has always been." And they actually improved, and we are now able to release without any issue.
Yeah, but of course, like for folks like you, like you're let's say you like come and you want to add something to OpenTelemetry, right? We totally understand that it's hard when you open up a project and there's like 1,000 Maven modules. It's hard for occasional contributors to come in and do this. Like this is absolutely definitely the case. We have started very slowly, I must admit, to take stuff out of the core repository and like put it in what we're going to talk about later, the Quarkiverse. Like there's always pushback. Like everybody thinks that their thing should always be in the core repo and not like in some other in the Quarkiverse. But yeah, this has served us well, but we're slowly starting to like decompose it, let's say, right? So the Quarkiverse that I talked about, right? So initially this didn't exist. Probably for the first like 2 or 3 years of the project, this didn't exist. So we were actually forced to throw everything into the monorepo. It's stuff that should never have been there. Was in there initially because we didn't have any other place to put this. So what Quarkiverse is, it's a GitHub organization where Quarkus contributors, like not only us, but folks that like maintain their own Quarkus extensions, they can have their own repositories in Quarkus in the Quarkiverse that have their independent release cycles, right? So let's say you maintain an extension for one of the obscure testing libraries you were talking about. You don't have to put that in the Quarkus main repo. You can put it in the Quarkiverse. You can release whenever you want. You can do whatever updates you want. And what we provide for you is like, first of all, there's a template, right? When you create a new repository, the structure of the Maven project is created automatically for you, so you know like exactly where you have to go and make changes. Second of all, I would think this is like the most important one. You can release to Maven Central without having to set up a bunch of different things. All that stuff is taken care of by the GitHub workflow, the GitHub Actions workflow that is all automatically set up for all these repositories, right? And the other thing is that we have CI set up for like changes that happen in Quarkus to be tested every day for all these repositories. So how many? Like 175 we say here? Yeah, so we test daily, like every morning, European time. We test like the entire latest Quarkus with like the latest version of all these extensions. So like I would say this is like a very good step to enable users. We've always wanted from the beginning, we wanted to be very open. We wanted to attract people, but it's not enough to say like, oh yeah, I want you to come contribute. Like you're welcome. You have to enable people, right? So I would say like the bad thing here is that it took us so long to do this, right? But like Guillaume said, when you're starting from scratch, there's like so much stuff you have to do in the beginning. So some things like happen later. I wish we had this earlier because it for the people here who do maintain extensions, like they know how wonderful this Quarkiverse is. Now, naming, right? Who is great? Who here is great at naming? I see. If you should come work with us, because we are terrible, and I mean terrible at naming. Right? We started out. Again, this is 2019. Like everything is like microservices, distributed, and reactive systems. Right? So we stuck reactive everywhere. Right? Everywhere. I'm talking about everywhere. We had REST Easy Reactive. We had reactive messaging. And that caused so much confusion to people, right? Like when you hear REST Easy Reactive, what do you think? You're like, well, yeah, this only works for reactive. Like, why would this work in normal blocking mode? And you'd be absolutely right, right? And worst of all, we also had Hibernate Reactive, which Hibernate Reactive only works in reactive. So we weren't even being consistent in what we were doing. Right? We have REST Easy Reactive, which works in all modes. We have Hibernate Reactive, which only works in reactive mode. We have reactive messaging, which works in all modes too. So we were needlessly causing confusion for everybody. And if you want like more proof of how terrible we are at naming, I'll just tell you. Like when we started, myself and a couple other folks, we started working on the replacement for the original REST Easy, which now we call Quarkus REST. Initially, when the project started, it was called QRS, right? Whatever. Then, about a month in, we had most things working. So we're like, okay, yeah, this name's not good. We're going to call it Quarkus REST. Quarkus REST, good. That's a cool name, right? But then, for our own reasons, we had to rename it to REST Easy Reactive. Terrible. And now we've come full circle, and now we're calling it Quarkus REST again. So, it took us years to come full circle and figure out what a good name is. Reactive messaging. Now we're calling it Quarkus messaging. Great, right? That's exactly what it is. It's not reactive messaging. It's messaging for Quarkus. Hibernate Reactive remains Hibernate Reactive because it is reactive only. That is a good case of what the name should have been initially. So you have Hibernate ORM, which is like the blocking version. You have Hibernate Reactive, which is the reactive version. I should say, one thing that we did very poorly in that space is that up until very recently, I don't know, maybe 1 or 2 months ago, you could not use these two versions together, right? You had to upfront pick and choose that I need ORM or I need reactive, which was antithetical to what we did with everything else. With everything else, we were saying, you could pick and choose. At runtime, you can have both working together for some endpoints. Let's say you could have them REST endpoints, you can have them reactive. For some endpoints, you can have them blocking. But no, with Hibernate, we had this artificial split that took us years to address, right? But the good thing is we fixed it a few years late. But
it was fun renaming all those artifacts.
Yeah, I mean, it's tough.
So we did the hardest, the naming. Now we will start with the easier things, or build time tooling. So Georgios explained how we reinvented how you built your applications. So you need some tooling to do that. The first building step that we have is that we have a framework that allows us at build time to consume some items, do something with them, and produce some other items. So typically, a jar is an item, and it's a final one. It's the final artifact that we want to produce. But then you have a whole tree of how will I get to this jar. And this whole tree is composed of build steps, which are just annotated methods that consume these items, produce the other items. And we have a large tree of things we need to do at build time, and we parallelize that to produce the final artifacts. This has proven to be extremely flexible and extremely useful to us, and this is what allows you to actually execute things at build time with Quarkus.
I should add, though, that the fact that you and I think it's flexible is at the detriment of the person who actually created this. The person who created this is like, no, you should never have done that. But we've bended it in ways that, were not anticipated.
And the second thing that we are using a lot at build time is Jandex. So Jandex is our index of everything you have in your class path. It indexes your classes, your annotations. So when you are at build time in Quarkus, you can say, oh, who is using this annotation? Who are the subclasses of this particular class? Does this class has interfaces or whatever? You can query everything you need. And this is important because when we are executing these build steps, I took the example of Hibernate Validator. We will say, oh, get me all the constraint annotations that are in the class path, because the user can create his own annotation. So get me all the constraint annotations, then get me everything that is annotated with one of these constraint annotations. Once we have the list of everything annotated, we can create the metadata upfront. This means that, again, we will be able to do more work at build time and less at runtime. And that's how we produce our metadata. And this is really a foundation of Quarkus. We are doing that in all our extensions. The other thing, I don't know if some of you try to write bytecode with ASM. Oh, okay.
Very nice. Very nice.
Would you recommend that to a friend? Okay, there are crazy people there, but I think maybe they are the ones that are good at naming, so we will probably hire them both. So this is a nightmare. Writing bytecode with ASM is really, really nightmarish. It's doable.
No, now with AI, actually, it's much more doable. No, I'm serious. I'm serious. Yeah. If you ask like Claude, like I need to transform this, it will give you a pretty good thing.
Okay, but how do you check it's right?
You run it.
Yeah,
and if it runs fine, you have a bunch of tests.
Yeah, and you try to understand what it's doing. But still, at this time, AI wasn't existing,
exactly.
So we needed something to simplify writing bytecode, because in Quarkus we write a lot of bytecode. When we are at build time, we scan everything, we do all sorts of crazy things, and the result is that we generate some bytecode for the startup. And this is one of the reasons why we are fast at startup. So we developed this library that is called Gizmo on top of ASM to simplify that. And we are currently transitioning to Gizmo 2. And Gizmo 2 is built on top of the classfile API that was introduced relatively recently. And some crazy guy in the Quarkus team actually decided to extract it from the JDK so we can use the classfile API with Java 17. And this is what, if you are using the latest Quarkus, this is already what you are doing right now. You are using the classfile API, and if you're using Java 17, it's using a specific jar that we have there. So this is all good, and this is things that really enabled us to do our job, but also enable us all the extension ecosystem to write extensions. These tools are in the hands of all our contributors. Problem is that we need our own tooling. So we need our own Maven plugin because we have these build time dependencies that are not visible at runtime, so we need to resolve them. We have our specific built infrastructure, so we need to do things, and we need a Maven plugin for that. Meaning that when Maven 4 pops up, we have to do some work to be compatible with it. And it's even harder with Gradle because we don't have that much expertise for Gradle in the team. And with Gradle, you have like millions of ways to do the same thing, and it's quite hard to figure out what's the best approach and what will be the best approach in the next version of Gradle. What is also harder than with your usual typical Java framework, we just take your classes and build a jar, is that we are building our own jars. We are producing a lot of bytecode. So when you talk about build reproducibility, the fact that with the same input, you will get the exact same jar output, for Quarkus, it's harder. We have to figure it out by ourselves. So the jar part is easy. You just need to order things properly, get the timestamp right. This part is easy. But then you have to think that we parallelize all the build steps, and in these build steps, we are generating bytecode. So all this bytecode that is generated needs to be reproducible. And this is harder than it looks. we have made good progress about it, but it's still not a solved issue, and we are still working on it.
Yeah, so here's another thing, right? Quarkus from day one that it was released, and actually I should say even say developed, it had GraalVM as a target, not the target, it's a target in mind, right? GraalVM existed at that point in 2018, so we're like, you know what? We all already want to do a bunch of stuff at build time, and using GraalVM to create a native executable makes 100% sense. Right, but there's a sort of complication we'll talk about soon. What we do essentially when we build a native image is, like Guillaume said, we use those build steps to actually create a bunch of bytecode, and we create a jar. And in this case, it's not the actual fast jar we talked about earlier, which runs when you target JVM. It's a native sources jar, which all it does essentially is it has the sources of all the code that we're using. Then we feed that to GraalVM, right? And then GraalVM, like I said earlier, it executes all the static blocks of each class it can find, takes a snapshot of the heap, and then creates the next native executable. And that's been our vision from day one. But the complication is that GraalVM, like before it takes a snapshot, it actually checks in the heap if there are things like random inside, right? Because when you're creating a native executable is a static thing. So that static thing should not have information that is only relevant at runtime. So a random, right? When you're creating a random number, that normally should take information from the system it is running on, right? Or you can't have a thread in a static block, because a thread is something that runs always at runtime. So what we, like from day one, like when Quarkus was built, the idea was like, let's squeeze the maximum amount of performance out of these native binaries, right? That was the idea from day one, because GraalVM was so revolutionary. Like it took Java to the next level, because at that point, up until GraalVM came around, there was like no way for a Java application to compete with a Go application. GraalVM made that possible. So we were thinking, okay, you know what? Let's do whatever we can, make everything known, as much code as we can, make it known to GraalVM, let it compile everything, let it shake the whole tree, and make it as good as possible. But the side effect is that we do that with your code as well, too, right? So you write something, or you write a support library, or you even an application, right? That means that if you are an advanced Java user and you go ahead and you create these static blocks and you do weird things in there, which in JVM mode is totally legal and totally legit, right? A real reminder, static block is the block that executes when the class is loaded, right? Not when it's instantiated, when it's loaded by the JVM. So if you look at like things like Netty, they do a lot of stuff in there. And you can do it too. So when we create an extension for, let's say, Netty, we know what Netty is doing. We know how to deal with all that. But it's probably not been a good idea to take your code and assume that, yeah, you know what? I know what you're doing in the static blocks. I'll just push that to GraalVM for static compilation as well. We've been in communication with the GraalVM team multiple times. They're like, yeah, you guys, you probably shouldn't be doing this. You should change this. Like, we understand what you're trying to do. You're trying to make everything as lean as possible. But it probably doesn't make sense for user code. So stuff that is added by your support libraries or your application, it probably doesn't make sense to statically build that as well. Now, the good thing is that we are reconsidering this choice. Like, this has been an occurring theme. Like, somebody will come and they'll say, you know what, I'm using this library and like it doesn't work in native because it's using a random or a thread in static. What should I do? Blah, blah, blah. So we're taking that into consideration. But there's also an additional point here. That GraalVM is likely in a few months or a year time frame coming out with a new sort of improved way to create native executables using layers. And this will tie in very nicely to our reconsideration of this fact. Now, okay, dev mode and test infrastructure. Like anyone who's used Quarkus, like we've never heard anyone say that like dev mode is not good. Everybody's always like, wow, this is like a huge productivity boost. And it is, right? It's great. We use it ourselves when we develop Quarkus applications. It's very, very cool. But, okay, let's go over again, like why it's good. It's good because like live reload that actually works. Again, like zero configuration. Doesn't matter whether you're using VS Code or like VI, whatever, ambient Quarkus dev, and it just works, right? Continuous testing, again, just works. You don't have to do anything. The infrastructure we put in place led to like dev services where you launch containers automatically, and the dev UI, which gives you a very cool view into like what the application is doing, and you can change stuff. Now that's all very good for users, right? And we want to make it as great as possible for users. But it creates a huge amount of pain for us, right? And no, but that's good. That's good. We want to take the pain so you folks can like develop as easy as possible. And what do I mean by pain, right? Anybody who's ever worked with class loaders, like I only know, yeah, excellent. Who here enjoys working with class loaders? Nobody. There's only there's one person.
They are the same. The same people.
So yeah, we had like two people on the team, Stuart and David, who like actually enjoyed working with class loaders, right? And they understood all the intricacies, all the weird things that JVM needs with class loaders. But the idea is that when you use class loaders correctly, they can enable amazing features like the dev mode, right? The fact that we load your user code in this runtime class loader, right? This is what contains your code, and then when you change something, then we just throw this one away and create a new one that contains this, and then that is what's running. This infrastructure, let's say, makes it an amazingly good environment for people to program in, right? But it creates a whole lot of complication for us. But it also creates a complication with libraries that are not aware of the fact that the JVM supports this hierarchical class loader structure, right? When you think about your typical like Java stack, right? Either like a micro framework or like something like Spring Boot, let's say, all those have a flat class loader. Like there's one class loader that loads everything. And in that case, you don't have any problems with libraries that are misbehaving because there's only one class loader. But let's say we've encountered cases where libraries will cache the loading of a class just by name, right? And this is completely wrong because when you're doing class for name and you pass a name, that's not the only key. There's also a class loader that you need to pass. And if you're caching based only on the name, then when you reload the application, like users are going to come to us and say, "Oh, well, your dev mode doesn't work." And typically they're right, but it's the library that's actually doing something that is completely wrong. Now, the other thing that lots of libraries do wrong, again, not because like they don't know what they're doing, it's just because this problem never came up with the majority of applications, is that they load classes from the class loader that actually loaded the class itself, right? But the proper way here to load for a library that has to dynamically load a class isn't to use the class loader it's actually using. It's to either be passed in a class loader, so Quarkus would determine, or a class, or like the thread context class loader is the saner default. All this to say that like this infrastructure has created us a lot of problems, but it makes things great. Oh, and the other thing we were talking about earlier, that this setup here creates the worst possible kind of memory leak that you can have. Class loader memory leak. If you have a class loader memory leak, it means that your class loaders keep in the meta space and the heap all the classes that have been loaded by that class loader. So we have had to go through multiple times, like libraries that or our code that have been doing something really bad. That the result being like when you reload Quarkus like 10 times, you're seeing like 5 gigabytes of memory being used, and it's always a huge pain for us to try and figure out like what happened, right? But the result is like we always consider this like a top priority bug. We always fix it, so you don't have to care, right? Now, API choices. So very early on, I'm not going to say from day 0 because this is incorrect, but from like I don't know, before the first release, public release, we decided that you know what, we have a very good base layer for all the I/O related stuff in Vertex. Does anybody use Vertex here? Few people use Vertex. Yeah, so Vertex is an amazing like toolkit, I should say, amazing toolkit for creating networked applications, but it's very hard to use, right? It's very hard for, we honestly don't expect users to use this directly unless like they have like very specific needs, like I don't know, some kind of edge gateway or something like that, right? But the good thing is that this is it's also based on Netty, so it's extremely well battle tested. It has extremely good reaction to CVEs, HTTP CVEs that always come, right? And it performs amazingly well. I think like raw Vertex is probably like the best performing I/O layer in the JVM space, right? But that also means that we have people that work on new stuff like HTTP 3, right? Where we're actively working on HTTP 3 now, or I/O Uring in Linux, which is like the new way to do I/O, which is much faster. So this is like Vertex is a large investment done by Red Hat, IBM. But it continues to pay off because like once Vertex supports, let's say HTTP 3, we get that almost for free in Quarkus. Now, the flip side of this is that like when we move from, let's say, Vertex 4 to Vertex 5, which will happen in the coming months, and we'll have to do Quarkus 4, is like there will be changes throughout the code base that will break like everything, right? So we're going to have a lot of work to do to move up from Vertex 4 to Vertex 5, but most users, since they don't use Vertex directly, won't have to care about this at all. Now, you want to, yeah, okay, so a thing that occurs very often, right? We have people from 2 different camps, like the Jakarta camp. We're like, oh yeah, we want everything standardized. Like you folks should always use like the Jakarta standards or the microprofile standards. And you have other people from the Springlands like, I don't care about standards. Just give me like what everybody uses. Just give me what's easy to use. So there's always been a tension here, right? Standards versus de facto standards. Now, from day one, Quarkus has tried to be like very pragmatic, right? Like we're trying to meet people where they are, but also push innovation as much as we can. So sometimes we use standards, sometimes we don't, sometimes we bring our own APIs. It's very hard to find the right balance. And an example is Panache, right? So it's our idiomatic layer for accessing databases. Now, I've heard this multiple times. Like it seems too foreign or too innovative for Java developers to have like active record style access, right? And a lot of times people will come and say like, Panache, great, right? But I just want like something like Spring Data JPA, right? Like give me that. That's what I want. That's what I'm used to. That's what everybody on my team is used to. Give me that. Or people will say, look, I don't want Hibernate at all, right? You just give me Spring Data JDBC. In that case, what most times they're not aware of is that you can get very similar functionality from Hibernate using stateless session, right? Stateless session is like this API that's been there forever. It's probably not extremely well documented, but it's very good. But the good thing is here, Panache 2, which will hopefully be coming in the next few months. We'll have Jakarta Data support. So Jakarta Data is like a similar idea to Spring Data JPA, but I think it takes it to the next level. Panache 2 will allow you to do like all this different kind of stuff in a very cool API, more easily digestible. Now, observability. Now, we've made a lot of changes here, but I would say it's mostly not our fault. Right? Because the observability space has been shifting under us so much the past few years. So Okay, we started with microprofile metrics, which that was definitely a mistake because at that time, like micrometer was already there. We should have just used that and call it a day. But for example, in tracing, we started with open tracing. That died. We move over to open telemetry, right? Logging. Now there's the open telemetry logging thing. We support that, right? And then for metrics, for example, now there's Prometheus version 1 versus whatever was the previous thing. Again, we have to migrate from one to the other. So there's always a cost of migration here. We try to keep things have the smallest blast radius as possible, but it's just not we're not able to contain it as much as we like because the industry is shifting so much. Now JSON, right? We started with JSON-B. Who uses JSON-B? Few people. REST, I assume everybody else uses Jackson, right? Like everybody just uses Jackson. We started with JSON-B, bad choice. We should have used Jackson. Jackson is everywhere. It's the most battle tested. It fixes CVs all the time. It has the most features. We still support both, so you can opt into whatever you want, but we usually recommend people to use Jackson, which is not a great thing for us now because now we have to do Jackson 3, which will require a whole bunch of coordination across like our entire suite of projects because Jackson 3 is a break and change, different package, different everything. So, but we'll take care of that. So you folks won't have to. We'll have like a Quarkus CLI update, do everything for you.
Okay, the community is an important part of an open source project, and when I talk about community, it's both the users and the contributors. We got extremely lucky, and it's also a lot of hard work to keep contributors coming, make sure the contribution experience is nice, and be nice to everyone. We had a lot of very enthusiastic contributors at the beginning. They came, Quarkus was exciting. Some are still around, some are still doing amazing things. Some, well, life happened, they switched jobs, got a partner, kids, whatever. We have new ones popping up regularly. It has been really amazing to interact with all of them. We met some of them at Devox this year. And one thing is, and it's what Georgios was saying, a bit about the size of the project. The project is also moving at very fast speed. And it's sometimes hard for an occasional contributor to keep with the speed. So thanks really to all these contributors who helped make Quarkus amazing. We also got help from a lot of people. I won't name them all. But yeah, a lot of companies or individuals helped us with various topics, various difficulties. And yeah, special shout out to Modern. They have a booth here at Devox, and they have been extremely helpful with open rewrite stuff. We contributed a bit, but they have been helping us a lot with recipes and bug fixes and things like that. So we are an open source project, so being open is extremely important. We recently moved to the Common House Foundation. The Common House Foundation is a neutral ground for projects. The nice thing about it is that it allows us to come with our processes, with our governance, and it's very flexible about it. All the IP of Quarkus, the domain names, moved to the Common House Foundation, so Quarkus will stay open source forever. And it's also a statement that we are welcoming contributions from other companies. If your company wants to contribute to Quarkus, wants to even if they want to start a Quarkus product or whatever, it's possible now. We are in a neutral foundation. Opening the code of a project is really the easy part. You push the code to GitHub, you put a license on it, and it's done. Problem is that the project is not only its code, it's everything that is about, it's the meeting that we have to decide things, and we are opening some of our team meetings with for external people. The design discussions, we started the working groups in the open to be able to say, okay, if you are interested in this topic, come, give us your ideas, get involved in the discussions. And then we also try to document our decisions in the open. We started this architectural decision record things to make sure that when we take a decision about the project, it's documented for the future and for all the contributors of the project. We still need to improve on making it sustainable for an occasional contributor. If you contribute on your spare time, it might be hard to find time to get to a meeting or get involved in very detailed design discussions. We are releasing very often. This is one particularity of Quarkus. It was very important at the beginning, but it still is. We release a minor every month, micros every week. We sometimes do emergency releases when a CV pops up. It's appreciated. We have a lot of people using the latest. But still, we also had people complaining about, oh, I'm tired of updating Quarkus every week and a new minor every month. It's just not working for me. So we started these LTS releases. Every 6 months, we pick a version. We make it LTS. We will support it for 12 months. And we release new micros every other month. And the usual question is, what if there is a CV? If there is a CV, we do emergency releases for the LTS, and we make sure that you get your CVs early. We also put a lot of automation into place. We discussed a bit about this last year at Devox. The fact is that at some point we were unable to actually do our job because we were triaging issues, reviewing pull requests, digging into logs to understand the failures, and this was not bearable. So we put automation into place incrementally. We have a bot on GitHub who handles a lot of things for us. We improved a lot the build reporting. When you have a pull request failing, we have a nice report with the failures, links to the test, and a lot of things related to it. We also automated our releases because we release extremely often. So if you have to do it manually, it's just a nightmare. So we have this nice action that is, so we actually start a release by creating an issue. And we discuss with the GitHub action saying, okay, I approve this. And the GitHub action is executing all the steps sequentially and asking you questions when it needs input. All we did is backed by Quarkus. We have 2 extensions, GitHub App, GitHub Actions, to actually power all this automation. The ecosystem CI, Georgios talked a bit about it. It's the idea that for all the extension ecosystem, we want feedback. We want to make sure that when we push something to Quarkus core, we don't break our whole ecosystem. This has been extremely useful. Roberto here sometimes did some changes to the small I config, and the next day we have a few extensions failing, and we can have a look and make sure that maybe it's normal they failed because they were doing something that was not legit. But if it's not normal, then we have to fix it in Quarkus. Why are we using our own stuff? Because supply chain attacks. We are extremely cautious about using random GitHub actions from the internet because you never know who is maintaining it. You never know who will maintain it in the future. It's extremely risky. It's the exact same thing for the GitHub apps that you can find everywhere on GitHub. We are cautious about that. And we also think that dogfooding is cool. So using Quarkus for this is extremely nice.
Okay, so yeah, so we're very short on time, but this one is very easy, right? Marketing, not good for us. Okay, so obviously, like in 2019, it's hard to know like where we're going to be in 2025. But with hindsight, which is always 2020, we definitely put too much emphasis on the fact that it's being reactive, which confused people into thinking that it was only for reactive. One that we get even today on a daily basis is like, oh yeah, why would I use Quarkus? That's only for native, which is completely wrong, right? But I can understand why people think that. Our messaging mentions native everywhere. We mention cloud native Kubernetes everywhere in our marketing material, which leads people to think that, you know what, you can't do regular monolithic applications with Quarkus. So we are aware of all that. We're definitely going to fix all this. The gist is that like getting the proper message out is hard. Right, so we only have like 30 seconds. AI, obviously we have to talk about AI in the conference. All we can say here with the time we have is like we were very lucky that we were early adopters of LangChain4j. We put a ton of effort into it, and it's been a very good boost for the project. With the fact that we have our own I/O layer and we have so much expertise has allowed us to, for example, create MCP integration, which is, I think, the best by far in the Java ecosystem. We're actually even starting now to put AI inside the Dev UI if you want to use it. So it can do like super smart things, like tell you like how to write a cron job, or how to write have it generate a client, or how to write a query, things like that, right? So
yeah.
Go ahead, yeah.
Yeah, we did a lot of things extremely good that allowed us to do to keep the promises we made at the beginning, the fast startup, the low memory footprint. These are promises that we kept. But it also allowed us to do a lot of nice things that we didn't envision at the beginning. Continuous testing wasn't in our minds when we started Quarkus, and it became a reality later. So the choices we made for the foundations allowed us to innovate again and again. Then we also made some bad choices. We explained this a bit, and what we wanted to explain here is that we learn our lessons and we are trying to fix things. And if you have more feedback about all of this, please come see us. We will be there at the Red Hat booth and talk to us about what you like and what you don't like about Quarkus. And yes, thanks everyone. Thanks Aaron for all the illustrations. You allowed us to use them. We had a nice slide for the questions, but we don't have time for them.
So yeah, we'll be here at the conference. Find us later.
Yeah.
Thank you very much.
Thank you.